Are continuing looking at our transformations, and this time we're going to be paying close attention to how they affect our domain and our range. So starting with this particular graph, I did forget to include it on this piece of paper, but this is what it looks like. So this is part of our absolute value parent function, and we're just looking at it from the domain when x is -3 to +3. So just those values. So our initial domain from the parent function we're looking at is from -3 to +3. And if we look at our range of this graph, I don't have arrows going off to infinity here, so it's just in the range from 0 to +3. So I'm going to write that down on my graph, or on my sheet as well. So this is our parent function. And some points that are on this parent function are 0, 0, -1, 1, -2, 2, -3, 3, 1, 1, 2, 2, and 3, 3. And so I am going to make that a table at the top. So this is my domain, my range, and these are the points of my parent function. And I'm going to continue it over here because I'm running out of room. All right, so those are 7 points on my parent function. Remember, this is what it looks like. It's part of our absolute value parent function. So we are going to be graphing these different transformations and then stating the new domain and range. So starting here on number 1, I have f of -2, and that is going to be a horizontal shift to the right 2 units. So over here, I'm just going to write one more time the points from my parent function for reference. And when we have a horizontal shift, that means that only my x values are changing. And if they're shifting to the right, that means they're going to be increasing. So I'm going to add 2 to each of these x values. And my y values are going to stay the same. Okay. And now I'm going to graph that. So my new domain, and I'm just going to write it in interval notation, is from -1 to +5, and that's brackets. And my range is still from 0 to +3. My range did not change when we moved horizontally. Okay. Moving on to number 2, f of x plus 1, that is going to be, again, a horizontal shift, but this time we're going to the left because it's plus. So my points from my parent function and my transformed points, only my x values are going to change because we're shifting horizontally, so my y values will stay the same. And when I'm shifting left, they're getting smaller, they're decreasing. So I'm going to subtract 1 from each of my x values. Okay. And we will plot our new points. And there is my transformed graph. So my new domain is from -4 to +2. And my range, again, did not change. When we shift horizontally, it only changes our domain. Okay. Moving on to number 3. F of x minus 1, that is going to be a vertical shift down because it's negative. So the points on my parent function When I shift down, only my y values are going to change. And going down on my graph, they decrease. So I'm going to subtract 1 from each of these, y values. I apologize. Brain fart. And my y values are going to stay the same. So now we'll plot our points. My domain is still from -3 to +3, but this time my range has changed. It's now from -1 to +2. So when we shift vertically, it changes our range. Okay. Number 4, oops, focus. I, again, here with the +2 on the outside, that is a vertical, oops, wrong color, vertical shift. And this time we're going up. We're going to go up 2. So the points from my parent function. So if we're shifting up 1, that means that they are, sorry, we're shifting up 2, that means that they're going to be increasing by 2. So I'm going to add 2 to each of my y values. And my x values are going to stay the same. And we'll plot our new points. There's my transformed function. My domain is from -3 to +3, and my range is now from +2 to +5. So vertical shift changes our range. Number 5. Here we have a negative in front of the function, so that means that we are flipping across the x-axis. And when I flip across the x-axis, this is my x-axis right here. So remember, this is what our parent function was. I'm going to graph it really quick just for reference. This is our parent function. When it flips across the x-axis, it's going to be going downward, which means that my y values are going to be changing, and they're going to be changing sign. So let me get our points in there for reference. So when my y values change, we're just changing the sign. So since they were all positive here, they're all going to become negative. And my x values are going to stay the same. And we plot those points. And there's my transformed function. My domain is still -3 to 3. And my range is now from -3 to 0. So when we flipped across the x-axis, it changed our range. Now we're going to get into some stretches here. I have 2 on the inside of my parentheses being multiplied, so that's going to be horizontal, a horizontal stretch or shrink. And then because this number is greater than 1, it's going to be a shrink. So this is a horizontal shrink. So again, I'm going to get the points from our parent function on here. Now a horizontal shrink means my x values are going to be getting smaller. So my y values are going to stay the same. And on my x values, I'm going to divide each of them by 2 because we're shrinking them. And this could also be in decimals, so you could have like negative 1.5, negative 0.5, 0.5, and negative 1.5. And now I'm going to graph my new points. So we shrunk horizontally. The x values got smaller. So my new domain is from negative 3 over 2 or negative 1/2 to positive 3 over 2 or positive 1/2. And my range stayed the same. Horizontal shrink. All right, we've just got 3 more here on the back. Number 7, again, this is inside the parentheses, so it's going to be horizontal. And because this is smaller than 1, it's going to be a stretch. So my x values are going to be getting smaller. So I'm going to be multiplying each x value by my denominator. I'm going to multiply each x value by 2. And my y values are going to stay the same. And we'll plot those new points. So we stretched it horizontally. So my new domain is from negative 6 to positive 6, and my range stayed the same. So horizontal stretches and shrinks affect the domain, and our range stays the same. All right, on number 8, I've got this times 2 on the outside, which means it is going to be a vertical change. And because this number is greater than 1, it's going to be a stretch. So remember, whether it's a stretch or shrink is opposite for horizontal and vertical. So when it's greater than 2 in a vertical change, it's a stretch. So we're going to be changing our x values only. And they're going to increase by a factor of 2, which means I'm going to multiply each of them by 2. And then we'll plot our new points. And so we stretched in the vertical direction. We got taller. Our domain stayed the same, so it's still negative 3 to positive 3. But our range now goes from 0 to positive 6. So when we have a vertical stretch, it changes the range. And last but not least, I have this 1/2 on the outside, which means again it's going to be a vertical change. And because this number is less than 1, it's going to be a shrink. So a vertical shrink. So what I'm going to do is leave my x values the same. And I'm going to divide each of my y values by 2. And again, you could do these as decimals. That is totally fine. And now we graph. And so you'll see we got shorter in the vertical direction. It got shorter. So our domain stayed the same. It's still from negative 3 to positive 3. And our range got smaller. It's now only from 0 to 3 over 2 or 1/2. Okay. So vertical stretch and shrink affects our range. Horizontal stretch and shrink affects our domain. Horizontal shifts affect our domain. Vertical shifts affect the range. And a flip across the x-axis affects the range.